And so in this first example, you can see Sammy zooms around an ice rink frantically chasing a puck. Puck is spelled wrong. Suddenly, Sammy is confronted by Tim at rest directly in his path. Rather than knock him over, Sammy picks him up and continues in motion without braking. All right, so with this one, we can assume that Tim, right, has zero momentum because he has no velocity. But Sammy's the one with momentum. And so Sammy's momentum is easy to calculate by just using the formula P equals mv. All right, so plugging in those values, Sammy's mass is 86 kilograms, and his speed is 4.2 meters per second. So 86 times 4.2, that's going to give you a value of 361.2 kilogram meters per second. That is his momentum. Tim's momentum, on the other hand, before hitting is going to be zero. Like I said before, he's got no velocity, therefore no momentum. Now, Sammy and Tim's total momentum, you would combine both of them. So Sammy's oh boy, Sammy's plus Tim's. And since Tim's is zero and Sammy's is 361.2 plus zero, basically this is the momentum of this system. So now for letter D, after the collision, does Sammy's speed increase or decrease? Well, Sammy's going to add more mass to the system by picking up Tim. And so therefore you should be already thinking that his speed is going to decrease. And Tim had no velocity. And since he gets picked up by Sammy, for crying out loud. I'm not sure what's going on now. Therefore, his speed, Tim's speed, is going to increase. So after the collision, what is the total mass of Sammy and Tim? So you add those together. 86 was Sammy's mass. Tim's mass was 65. Add those together and you get 151 kilograms. And so now after the collision, what is the total momentum of Sammy and Tim? Well, as we stated before, their total momentum is still going to be 361.2 kilogram meters per second. And use the conservation law to find the speed. All right, so we're going to find the velocity of these individuals. And so when we plug these in, you can see the formula here, right? You have Sammy's speed, Tim's mass, Tim's speed, Sammy's mass. And you can see mass times velocity plus mass times velocity 2 equals m plus v. And so if we know that this, right, is the momentum of both of those individuals at the beginning, we've got 361.2, right? This is basically both of their momentums. It's going to be equal to both of their masses. So Sammy's mass, 86 kilos, plus Tim's mass, 65 kilos, multiplied by their new velocity. Okay? So plugging in these values, you're going to subtract 86 plus 65 from this side. You add these together, and then you divide this side by 86 plus 65, and you'll do the same thing, 86 plus 65, and that should give you the velocity for this new system, Sammy and Tim. So hopefully that was helpful. Plug that in and you should be able to get that value. Now this one's a little bit more tricky because you can see we've got two carts and they're both traveling in opposite directions. And so the key to this one is figuring out which of these carts has more momentum. And I can see already that cart A has more mass It's traveling at a greater velocity than cart B, so therefore it's going to have the greater momentum. But first of all, you're going to calculate by using P equals mv for both of these. And then what is the momentum of the carts after they collide? And so this is a special case. They're going to cancel out basically the smaller one. So just subtract. So you're going to subtract cart A momentum minus cart B momentum. And that should give you the momentum of the new system once they collide with each other. We'll just assume that they connect with each other. So now after the carts collide, what you're going to do is find the new velocity of the two carts. Well, you'll know their momentum from here, from solving this in C. So whatever this momentum is, right, is going to equal to the mass of A plus the mass of B, right, all multiplied by V. And so plugging in the values for the mass of the cart right here, 56 kilos, 35 kilos here. And then you're going to solve for V by using algebra, just like you did in the Sammy and Timmy collision one. All right, the next one, we've got cart A is 45 kilograms. It's moving at 34 meters per second, and cart B is 57 kilos, so a little bit bigger, but it has a smaller velocity, but they're both moving in the same direction here, so they're going to couple, because you can see this cart is moving faster, so it should sneak up on this one and collide with each other. So these ones are easy. A and B, you're just using the momentum formula, P equals M times V for both of these. And what is the momentum of the carts after they collide? And so with this one, you're just going to add these two momentums together. Okay, this one's pretty straightforward. You're adding both of these, so the momentum of cart A and the momentum of cart B, because they're both moving in the same direction. So PA plus PB, cart B, should equal new momentum of this system. Okay, now after the carts collide and stick together, what is the velocity of the two cars? This again, you know what this is. You're going to be solving for V in each one of these. So after they stick together, right, you'll know their mass, you'll know their momentum, and so then you can use algebra to solve for this. And so you're going to take that new momentum, down she comes right here. So the combined momentum of cart A and cart B, so P, and you know their masses, right, from up here, 45 kilograms and 57. So mass A plus mass B multiplied by V. And that should give you the velocity of these two carts once they combine with each other. Last problem, number 4 here. This looks very similar to the first example where Timmy was sitting there stationary at the ice rink. You can see cart B is not moving. It's got no momentum. It's got some inertial mass, but it's got no momentum. And you can see we've got cart A is moving at 10 meters per second. It has 10 kilos, so it has less mass, but it's always going to have more momentum. So P equals M times V again. P equals M times V for both of these carts' momentum. And what is the momentum after they collide? And so what you're going to have here again, you know that cart B is 0. So it's basically whatever cart A's momentum is. But you should still do this. So momentum of A plus momentum of B equals momentum total of this system. And then again, you're going to calculate the velocity using that same formula you've been using since the beginning of this. You know their total momentum after the collision. So you're going to plug this down here. You know both of their masses. So mass A plus mass B. And that's going to be multiplied by V. And you're going to solve for V using algebra. If you've got any questions, send me an email about this. It's involves a little bit more math than maybe you're used to doing. So good luck.